Hey everybody, I'm just going to run through some of the practice exam questions, just hopefully to give you a little more comfort and see how you could do things efficiently. Keep in mind when you're importing any data, you always want to check and make sure that your data type matches what you expect it should. So we were asked to work with this specific conductivity data set that is continuous, so that looks pretty good. The first thing we were asked to do is describe the data, and whenever you hear describe the data, it means you're giving us a rundown of the descriptive statistics, enough that we could learn a little bit about that population, whether or not the data could be applicable to our studies, maybe give us some additional customized statistics like the skew and the kurtosis, maybe the interquartile range, so you can always add those things on, but definitely some measure of central tendency, some measure of variability, and then it's helpful for us to know whether or not we have outliers. And then also the real key is that we want to be able to test to see if our data is normally distributed. So I'm going to bring a continuous fit onto this and do a goodness of fit test. I have a p-value of 0.01 that is less than my threshold of 0.05, which means I need to reject my null hypothesis. Remember, the null for this test is that the data is normal. I have to reject that, so my data is not normal, which I probably could have guessed from all of those outliers and this skewed distribution. There's our skewness and our kurtosis were very peaked. So that means we're probably going to have to run some nonparametric tests. The next thing that you were asked to do was to remove outliers and see if that helped make the data more normally distributed. And instead of just using the IQR method, which JUMP already gives us, you were asked to do something a little bit harder, which was to figure out the thresholds beyond which only 5% of all possible values would fall. So I'm going to bring Excel in for that. The first thing I have to do is figure out the z-score associated with that 0.25% on, or 2.5% on one side and 2.5% on the other. So I'm going to use my norm S inverse function, and I want to use that 0.025 for the 2.5%. That's going to give me the left tail, negative 1.95. And I know that because of symmetry, that the right tail for the 2.5% is going to be the exact same thing, except it's going to only be, it's going to be positive. So I have my lower z-score threshold and my upper z-score threshold. I now need to know the actual data values associated with those, so I'm just going to transfer over some information. My mean for this data was 128.9, and my standard deviation for this data was 33.29. And I'm going to now just use the calculation to get my x value. I'll do it up here for my upper threshold. It was my z-score times my standard deviation, and then I was going to add my mean. That gives me the lower value. My upper value, it's actually the exact same formula, but I'd have to make sure that I'm locking down my mean and standard deviation columns. So I'm just going to F4 those to lock those down. So the only thing that's really changing is which z-score it's using, and I can verify that it's using the right cells, and it is. So there's my lower z-score threshold and my upper z-score threshold. What's nice about JUMP is that I can come in here and I can come to my row selection and I can select where certain criteria are met. So let me bring my Excel back over so I can see it. So I want to find all of my observations where my specific conductivity is less than, and my minimum number was 63.65. 63.65. I'm going to say OK, and hopefully it just highlighted any values that fall below. And there they are. Wow, I must have sorted this. So it's already highlighted them. I'm going to right click and I am going to say hide and exclude. I'll do the same thing to get rid of my upper threshold. So where specific conductivity is greater than my upper threshold, 194.14, 194.14. And I'm going to hopefully now see, look at that, 2,812. So I'm going to guess those are, oh, they're scattered throughout these 52,000 observations. So I'm just going to find any any one of these that's highlighted, and I can right click on that and do the same thing, hide and exclude. So now I can see that I've excluded and hidden 2,864. So those were my outliers based on that 5% threshold with 2.5% in either tail. I can just come right back up here, and actually it's nice to see that there probably is a lot of overlap between that 5% threshold and the interquartile range threshold that JUMP uses. So I'm not seeing those outliers there, but I want to rerun. I want to come down to my script. Actually, sorry, this would be the other magic red triangle. And I want to redo this analysis. So it's just rerun it, and I can definitely see that it's doing something different. But my goodness of fit test is still not normal. I'm still below 0.05. I have to reject the null. So even with those outliers removed, I still have non-normal data. So then I was saying, well, don't just use the thresholds, and I'll just shut this down. Well, no, I'll just pull it off to the side. If I want to put all these back in, so I just want to clear all of my row states, and now everything is back in, and I can verify that down here. And so now it's saying, go back in and just use that interquartile range technique. So now I can see all of these are back in. If I'm just using that technique, I come up and I hover, and I can get my lasso, and I can just grab all of these that are outside of that interquartile range threshold. So those are now all highlighted. And I come down here and I can see that it gives me 192 observations, give or take. So not nearly as many observations were pulled out by this IQR method as were pulled out by that 5% method. Right, so now it wants us to remove these. So same thing, except now since I'm doing it from the graph, I can just right click right in here, hide and exclude them all, and then again come back up to the magic red triangle and redo my analysis, and I'm still not normally distributed. Wow, tough data set. So none of these are going to work to bring our data into normality. So we're just going to have to go with the original data set. So I'm going to again clear my row states and know that we are going to have to just run non-parametric tests, right? So I'm just going to rerun that analysis just to make sure that I'm working with the full complement of data, all 52,330 observations. Right, so now it's asking a couple more questions where we might need some of this descriptive statistics information. So with all those outliers back in, we're just going to assume we have normal data. That's just fun for practice. And it's asking us to figure out what our probability, I'm on question 5 now, what our probability is of seeing values beyond this threshold of 175 of actual measured values. So the first thing I have to do is figure out what my z-score would be for that observed value of 175. So I have to calculate the z-score. Oops, and the formula for that was I was going to take my x value, and here they're saying it's 175, and I was going to subtract from that the mean of the data set, and then I was going to divide it by the standard deviation. So we have a z-score of 1.38, right? That's the z-score associated with the actual value of 175. But the question was asking what's the probability of seeing a measurement beyond 175, so I have to see the probability of being greater than this. Now I can use my norm s dist function, but remember that only gives me the probability of being less than that. So what I really want is 1 minus this. So there's about an 8.3% chance of seeing values above 175. Okay, now it's saying, well, what about the probability of seeing observations between this value and 150? So in other words, they're approaching this threshold. So now, and sorry, I can't sketch in this video, but now I'm still going to use this probability, but I have to, this was the one associated with 175, but I have to do the same thing for 150, right? So I'm just going to copy this exact same formula. Oops, sorry, I had to lock down my cells first. Right, I'm going to use that F4 function to lock those down. And now I can bring that over, but I want to make sure that instead of 175, it's 150. So there is the z-score associated with that. I should get the probability of being less than that. So I'll do my norm s dist. z-score. So this is the probability of being less than this one. How about if I change this back to being the probability of being less than that? And now if I just take the difference between the two, I end up with the probability of being in between them. So about 18% of all of our observations are going to fall between 150 and 175. Question 7 was still working with this same data, but they wanted you to test and see if this stream, the specific conductivity for this stream, differs from the larger population of all streams in Alaska, which have a mean of 125 and a standard deviation of 55. So if we were going to test that mean, we would come right in here, and so we hypothesized the mean of 125 and a standard deviation of 55 for our population. This is not normally distributed data, so I'm going to ask for that Wilcoxon signed rank. And so I have both the parametric z-test and also the Wilcoxon signed rank, and we were just doing a two-tailed test. Is it different, right? Is this stream here different from the larger population? So that's our two-tailed test here, and it looks like it is significantly different. Remember, if it is, you want to describe how, and it appears that our sample is significantly higher than the hypothesized mean of 125. So even though it doesn't seem like it's meaningful, and that could be because of the power of the test, we do have a significant difference. So if we were going to summarize this in one paragraph, we might say we tested to see if our specific conductivity in our stream differed significantly from the larger population of Alaska streams. A one sample z-test told us that there is a significant difference, and here's where I'd include that shorthand in parentheses. I would say z equals, and I would report this signed rank test statistic because we were doing a non-parametric test, and then I would say comma, and I'd report the p-value, p less than 0.0001. And then if you know anything about chemistry, you could use a sentence or two to interpret that and what it means. But that's it. We just basically ran a one sample z-test. The last question on the test was more of just having you practice interpreting significance and lack of significance. So remember, anytime you have a p-value less than that typical threshold of 0.05, you're significant. So this is a significant result. If your obtained value, even if it's negative, if it's more extreme than your critical value, then you have a significant result. Less than 0.5, don't get tripped up. Look at your decimal places, plus the greater than versus the less than. If you're that high, then you're definitely not significant. But if you're less than 0.05, you are significant. If you're accepting the null, that means it's not significant. Nothing is going on. If you're rejecting the null, then it is significant. If your obtained value is less extreme than your critical value, again, absolute value brackets here, then you are not significant, and this would be highly significant when you're that low. Okay, so hopefully this, I know it was a quick run through, but I also have the answer key down here. Hopefully this is helpful, and you guys will be confident and ready to tackle the exam. Happy test taking, everybody.